All right, folks, here we go. We are diving into Chapter 3 of AP Statistics, and the title of this chapter is Describing Relationships. So that word there is very important because it implies that we will now be looking at two variables rather than just one. So in the past chapters, we may have looked at the distribution of a single variable. Now we will be looking at the distribution of two variables at a time. So let's go ahead and start by discussing how we're going to build on what we've done before. So in the past chapter, we've talked about plotting data and then adding numerical summaries. We're going to continue to do that in Chapter 3, except the plot type we use will be a little different. Then we're going to also continue to look for overall patterns and departures from those patterns. In the past, you recall that when we were describing the distribution of a quantitative variable, we talked about shape, center, spread, and outliers, and we will be doing something similar in this chapter. Last but not least, when there's a regular overall pattern, we're going to use a simplified model to describe it. In the previous chapter, we had quantitative variables that had a regular overall pattern, and we used a normal distribution, which was a simplified model, to describe that overall pattern. We're going to do something different in Chapter 3, and again, this is all building up on what we've done before, but looking at it with two variables at a time rather than just one. So let's go ahead and get started on section 3.1, which is about scatterplots and correlation. And yes, this is the new plot type that we will be using in this section when we're describing, looking at relationships between two variables. Okay, we'll start with a definition. A response variable measures an outcome of a study, and an explanatory variable may help explain or predict changes in a response variable. A couple notes here. First thing is don't use the word independent variable or dependent variable. I know that you have used those words in the past in other courses, and that's fine. Your notion of independent variable and dependent variable will still be valid, except we're going to use those terms in probability, the term independent and dependent in probability, and I don't want to confuse those now. Just so you know, the connection between those words and our new words, our new vocabulary terms, explanatory variable is typically what we call the independent variable, and response variable is typically what we called the dependent variable. All right, another note here. Sometimes there's really no distinction between explanatory and response, but we can still investigate relationships between two variables. So there won't always be a clear-cut line as to which variable is explanatory and which is response. And we'll actually see that in the first example here. So example with weight and height. Tim wants to know if there's a relationship between height and weight. Kelly wants to know if she can predict a student's weight from his or her height. Information about height is easier to obtain than information about weight. Isn't that the truth? I will, without a doubt, tell you how tall I am, 5'11", but I am not going to tell you how much I weigh. That's a closely held secret. Okay, so for each student, let's identify the explanatory and response variables if possible. Well, Tim, there's no specific explanatory response. He just said he's looking for a relationship, so we don't have one that we will say explains the other. But Kelly, oh boy, Kelly, she's a crafty one. Height is her explanatory variable, and weight is her response. And the reason why is she is trying to predict weight, so it's the response variable. She's trying to predict a weight based on a height. So height would be explanatory. It would explain the predicted weight. Okay, so that's a quick example of how we're going to see those new vocabulary terms of explanatory variable and response variable. Now let's talk about describing scatterplots. You've seen scatterplots in previous courses, so I'm not going to read that definition to you. But what is different is how we'll describe them. Okay, so the first thing is this definition of association. Okay, we've talked about association in a previous chapter. We've said if there's an association between variables, then knowing the value of one variable will help you predict the value of another. But now we're going to add to that, and we're going to describe association as being either positive or negative. Positive association is what you would think of as a positive slope. As the explanatory variable goes up, so does the response variable. A negative association is the opposite of that. It is much like a negative slope. As the explanatory variable goes up, the response variable goes down. And when we go to describing a scatter plot, we're going to use these 4 different descriptors: direction, form, strength, and outliers. In terms of direction, we'll describe direction in terms of association. That'll either be positive, negative, or none. In terms of form, we'll focus on 2. We'll either say that our data, it has a linear relationship or a curved relationship. In terms of strength, we'll have a descriptor like weak, medium, or strong. And as we get further into this lesson, we will try to quantify the strength of linear relationships so that we're not so subjective with the terms weak, medium, and strong. Last but not least, outliers. Are there any observations that just don't fit the pattern that we see in the rest of the data? And if there are observations like that, we should address them. All right, so let's look at an example. Track and field day. Each member of a small statistics class ran a 40-yard sprint and then did a long jump with a running start. The table shows the sprint time in seconds and the long jump distance in inches. So we have data here on, let's see here, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different individuals. And this is paired data, okay? Meaning that for student number 1, they had a sprint time of 5.41 seconds and a long jump distance of 171 inches. So the problem states that we need to draw a scatter plot of the data and answer the question, what does it reveal about the relationship between sprint time and long jump distances for students in the statistics class? Okay, so I'm going to go ahead and create the scatter plot for these 2 distributions. Typically, we'll ask our calculator to do that for us, but we should also be able to do it by hand pretty quickly. All right, folks, there's the scatter plot of this data that shows the relationship between long jump in inches and 40-yard sprint in seconds. Just obviously, this is a tedious process to do this by hand, and if you do it with your calculator or with a computer, you will get more accurate graph, as well as it will be neater, prettier. But nonetheless, we should be able to do this on our own. And let's just now answer the question about what does it reveal about the relationship. Well, students who took longer to run 40 yards have shorter jump lengths. So there's a negative association between sprint time and jump length. And you can see that because the general pattern in this graph is that. It tends to go have a negative association. Longer sprint times are shorter jump lengths. There is a fairly strong linear pattern with no apparent outliers. So just want to make sure we check back to look at the description of a scatter plot, direction, form, strength, and outliers. I want to make sure that I've captured all of those. So do I have direction? Yes. Negative association. Do I have form? Yeah, I said it's linear. Do I have strength? I said it's fairly strong. And did I address outliers? I sure did. The one other thing I want to address here is I want you to notice how I structured my first sentence. So I said students who took longer to run 40 yards have shorter jump lengths. That's called describing association in context. You should always describe direction association in context. Don't just say the association is negative. You must describe it in the context of the problem. That means you should be using the explanatory and response variables appropriately, as well as describing the relationship between the two. Okay, that's enough for page 1. Let's move on to page 2.